Okay, so in this video we are going to look at the image formed by a convex lens. It's going to have a focal length of 6 centimeters. We're going to have our object 10 centimeters away from the lens, and the height of the object is going to be 5 centimeters. Okay, in real exam questions, some of this might be done for you, but I just want to show you how to do the whole thing from scratch if you ever needed to. So the first job is not to draw the lens, but first of all, I recommend that you draw the axis of the lens. Now, unless you know otherwise, the best place to do that is along the middle of the page. So there's the axis of the lens, the line that goes through the middle of the lens. Okay, perpendicular to that is where we're going to draw the lens itself. Okay, now it doesn't matter how big you make your lens, so I'm just going to use pretty much the whole height of the paper for my lens. And to show that it's a convex lens, remember I need these arrowheads like so. So there is my convex lens, there is the axis of the lens, ready to mark on some more information. So first I'm going to do the focal length, which is 6 centimeters. Now remember, there's a focus either side of the lens, so 6 centimeters away on that side there is a focus, and exactly the same on this side, 6 centimeters there is a focus. Okay, so that's all the information to do with the lens. I know it's convex, I know the focal length is 6 centimeters, that's all good. The next thing I'm going to do is to place my object. That was going to be 10 centimeters away from the lens, okay, which is there, and the height of that object was 5 centimeters. So with a ruler, let's just get that measured up. Now my object is a very simple object, it is just an arrow. It doesn't need to be any more complicated than that to show what we need to see. So that's all ready for us to start now thinking about our rays of light. Okay, we're going to do all 3 rays of light to illustrate the 3 rules that apply to convex lenses. 2 of these is enough to place the image, but we'll do all 3 just so you get the idea. So the first ray of light I'm going to draw is one that is parallel to the axis. Okay, and I'm just using a different color now to show that these are rays of light. So there is my ray of light. It is parallel to the axis. Now the rule for a ray of light that's parallel to the axis is that it is refracted so that it goes through the focal point on the other side of the lens. Okay, so I'm just lining everything up, and when I'm ready I'm going to draw in the line there. Okay, and if that's not long enough I'll just come back and extend it later. So there's my first ray of light. Second ray of light I'm going to draw is a ray of light that goes through the focus on this side. So starting from the tip of my object again, lining it up with the focus, that is going to go down there. And the rule for a ray of light like that is that when it reaches the lens, it is then refracted so that it comes out parallel to the axis on the other side. So this is now showing me where the image is going to be formed, where these rays of light meet. But just for completion, the third ray of light is going to go through the center of the lens. And what we know there is any ray of light that goes through the center of the lens is not refracted. It carries on in the same direction, which is lovely. So all 3 of my rays of light meet up at this point. So this is where I am getting the image formed. So that was the tip of my arrow. So this must be where I see the image of the tip of my arrow. So the rest of the image is going to look like this. Okay, so that was my object over there, and this is where I get my image over here. Okay, it's a image that's real. This is an image that I could project onto a screen. Okay, so convex lenses, the image can be real. If it's on this side and the object was on that side, it is going to be a real image. In this case, we can see it's also larger than the object I started with. This was 5 centimeters. If I carefully measured this with my ruler, that is about 7.7 centimeters. Okay, so something that you could be asked to do is to work out the magnification. Now that is simply the image height divided by the object height. So with a calculator we could just quickly do 7.7 divided by 5, and that will tell us the magnification of the lens. Okay, so calculator, 7.7 divided by 5 equals 1.54. Okay, so there is the magnification. Okay, it doesn't need any units because it is just a ratio between the height of the image and the height of the object. Okay, so I've got a real image, I know the magnification of the image, and the other key thing about this image compared to the object is that it is upside down. Okay, so that's all we need to do there. That is finished.